Chapter 8, Section 8, this will be a quick little review of rational expressions and rational equations. For the rational expressions, we're going to focus on simplifying them, multiplying, dividing them, and also adding and subtracting them. All right, and then at the very end of this lesson, we'll review how to solve a rational equation. I'm starting you off at example 3, and I'm going to have you simplify a rational expression. This is a rational expression. By definition, a rational expression is basically a quotient of two polynomials. And so notice that the numerator happens to be a monomial and the denominator is also a monomial. What we can do whenever we have a monomial divided by another monomial, what we can do is just divide out the common factors. So what I'm going to do right now is I'm going to rewrite the numerator using prime factorization, and the same thing for the denominator, and then I'll divide out their common factors. 10 has prime factors 2 times 5. 2 times 5 is 10, and then times k times r cubed, which is r times r times r. So that's the prime factorization for the numerator. The denominator, 25, is 5 times 5. K squared is k times k, and of course r squared is r times r. And then what we'll do here is divide out any common factors. So 5 divides out with 5, k divides out with k, r divides out with r divides out with r. And then your answer is the product of the remaining factors. So in the numerator, you have 2r, and in the denominator, let me make sure that looks like 2r for you, 2r, I don't know if that's any better, and then the denominator, you have 5 times k. So that is the simplified expression. We just divided out the common factors. Now, we only use this approach for the most part whenever we have a monomial divided out by another monomial. Let me show you the next example and how it is similar, but also how it's different. This next example has a trinomial divided by another trinomial. I'm actually going to give you example 4 part A and then example 4 part B. Check out part A. So notice the trinomial in the numerator and the trinomial in the denominator. Now, a common mistake some people make is they think that you can say this term divides out with that term, right? Furthermore, sometimes people say 4 goes into 8 twice. You can never divide out between terms. You can never divide out between terms. So all of that is not legal, if you will. Instead, notice in the previous example, once we had a list of factors or a product of factors, then you can divide out between factors. Right now, you have not factored the numerator, you have not factored the denominator. So until you factor, you can't divide out any of those common factors. So that's the idea. Let's factor first and then cross cancel. So you may want to add this to your notes, okay? It's very important. We never divide out between terms, okay? We divide out common factors. So the strategy is factor the numerator, factor the denominator, and then divide out any common factors. All right, so thankfully we spent some time in the previous lesson reviewing how to factor, right? So our factoring skills will come in very handy here. The numerator will factor as 3x and 1x, correct? And then you want to use factors of -8 and somehow end up with +2, okay? So what if we put the 4 here, a 4 here and a 2 here. Make this plus, and then a minus. Let's check this factorization. We already know that 3x times 1x gives us 3x squared, so that's good. We also know that -4 times +2 is -8, so that's good. What I'm really interested in checking, though, is that I get +2x as the middle term. 3x times +2 is 6x, And then minus 4x, that's definitely positive 2x. That's really good. Now, if I'm going to have any common factors, which most of these problems have common factors after you factor, then one of these factors down here probably matches one of these factors. So what I'm going to do is I'm going to step out on a limb here and say that what if the denominator factors as 3x minus 4 times something, right? I'm going to use that to try to help me factor the denominator. Now, it might not be, the denominator might not start factoring this way, but I'm going to step out on a limb and see if it does. Now, in order to get 3x squared, and if this is 3x, then this has to be 1x. And in order to get negative 4 times positive 1 will give me negative 4, right? All right, let's check to see if this factorization indeed is correct. 3x times 1x is 3x squared. Negative 4 times 1 is negative 4. 3x times 1 is 3x. 3x minus 4x is negative 1x. So that definitely works. So now I can divide out common factors. So 3x minus 4 divides out with 3x minus 4. And your remaining factors, the quotient of your remaining factors, is your final answer. Okay? So again, the instructions really, or the strategy really is factor, then cross cancel. Then you're done. Factor, cross cancel. All right, the next problem here, you have a trinomial divided by a binomial. All right, the first step, factor, right? Factor, factor, factor. Let's try to factor this numerator, and then we'll factor the denominator. At any point in this process, it would be really good for you, I think, to pause the video and try to factor these polynomials on your own. And then you can check, we can compare our work. The numerator will factor as x minus 12y, x minus 1y. The denominator is a binomial, and it's a difference. So it's either a difference, if it's going to factor, then it's either a difference of 2 squares or a difference of 2 cubes. I noticed that 144y squared is a perfect square, and so is x squared. So the denominator is a difference of 2 squares. We just reviewed how to factor a difference of 2 squares in the previous lesson. So it factors as 12y plus x, 12y minus x. Now compare your factors. Do you have any common factors? Well, this factor here is actually the opposite of this one. Let me show that to you. This is positive x. This is negative x. This is negative 12y, positive 12y. So these are opposites, and opposites always divide out, leaving you with a negative 1. Opposites always divide out, leaving you with a negative 1. So I have a negative 1. It's out front of my expression. The numerator is x minus y, and the denominator is 12y plus x. 12y plus x. I know that addition is commutative, so I can write the x first if I prefer. Okay? You could have left it as 12y plus x down there if you wanted to. So I wrote it as x plus 12y. Now, what you might want to do at this point, you might want to have less symbols by distributing this negative here, okay? And if you do that, you'll have less symbols, right? So your answer will look a little cleaner, if you will. And so what you can do is this negative makes this negative y a positive y, so I'll write that first. And then this negative makes the x negative, so negative x. And then the denominator x plus 12y. Okay? Now that we know how to simplify a rational expression, what we're going to focus on doing now is multiplying rational expressions. Now this is going to be a 2-step process, okay? So what we're going to do first is factor every single polynomial, then cross cancel, which is another way of saying dividing out common factors, and then you're done. Again, factor, then cross cancel. All right, this would be a great example for you a great opportunity for you to pause the video and try to factor these on your own, and then we can compare our work. All right, the numerator in the first rational expression factors as x minus 5, x plus 3. The denominator is a difference of two squares, so it factors as x plus 5, x minus 5. The second expression, the numerator factors as x plus 5 times x plus 4. And then the denominator of 5 is the GCF, leaving you with 5 times x plus 3. All right, so now look carefully and look for common factors. Now, because this is multiplication, right, you can cross-cancel any numerator with any denominator. Well, look for common ones, of course. So what I see is, x plus 5 divides out with x plus 5. Anything else? Yes, x plus 3 divides out with x plus 3. Oh, x minus 5 divides out with x minus 5. So all you're left with for your final answer is x plus 4 in the numerator over 5. That's the extent of these kind of problems, everybody. A factor, cross cancel, and then you're done. Check out this next example. You have a binomial being multiplied by this rational expression. In the numerator, you have a monomial, and the denominator, you have a polynomial of 4 terms. All right, again, I invite you, as always, to pause the video and to try this on your own. Now, this first binomial, the GCF is x. So I'm going to factor out the x, leaving you with 3 minus x like that. And then this denominator, first of all, the numerator is just x, so just write down x. This is a polynomial of 4 terms. So you're going to have to factor by grouping. Now, if you like, I can do this off to the side with you. Or if you want to try it on your own, that's fine. Of course, it's always okay. I'm going to factor out of 4. So I'm factoring by grouping right now. I'm going to factor out the GCF of 4. All right. The next step when I factor by grouping is to put these terms in 2 groups. By now, you're probably used to me grouping the first 2 terms together and the second 2 terms together. And then factor out the GCF from each term, each group, from each group. And so I'm going through this fast just because we had a whole lesson on factoring by grouping earlier. So I'm hoping that you feel confident now for factoring by grouping. So here, this is the factorization of that denominator. So I'm going to go back to our problem and put this for the denominator, okay? All right, I'm back to our problem, and now that I've factored every single polynomial, I want to cross-cancel or divide out any common factors. Now remember, this is the opposite of this factor, and the opposites always divide out, leaving you with -1, right? So you got to decide where you're going to put that negative in just a minute. Be careful, these are not, this is a numerator and so is this, so they do not cross-cancel. All right. I think that's it as far as cross-canceling is concerned. I have the negative out front. My numerator is just x times x, which is x squared. And the denominator is 4 times x squared plus 5. There's my final answer, everybody. I've decided just to keep the negative on the outside of my expression. Okay? All right, we've talked about simplifying rational expressions. We've talked about multiplying rational expressions. And now we're talking about division. Now, division, whenever you divide a fraction or rational expression by another fraction or rational expression, what we do is we keep the first rational expression the same for the most part, change division to multiplication, flip the second fraction. That is, basically, multiply by the reciprocal of the second expression. Sometimes I tell my students to KCF, not KFC, everybody, KCF. Keep the first fraction the same, change division to multiplication, and then flip the second fraction, KCF. That's how you divide a fraction by another. So really, this problem turns out to be a cubed minus 125 divided by 9a minus 9. Now we're going to change this to multiplication and then flip the second fraction. So 3a squared minus 3 over a squared plus 5a plus 25. That's KCF. Now you can see, oh, division just turns into multiplication. And I already know how to multiply, right? We talked about it in the previous example. So now we will factor every polynomial, cross cancel, and then we're done. All right, this is a great opportunity for you to pause the video, try to factor each one of these polynomials on your own. All right, the first numerator is a difference of two perfect cubes. So it factors as such, as like this. Okay, kind of ran out of room there. Let me fix this for us here. Extend this fraction bar. The denominator, the GCF is 9. There. The numerator, you can factor out a 3. After you factor out a 3, you'll notice that you have a difference of 2 squares, which factors as such. The denominator is prime. It does not factor. I know that because there are no factors of 25 that add to 5. Now look for common factors. Let's see. A minus 1 divides out with a minus 1. A squared plus 5a plus 25, that trinomial factor, divides out with that denominator. 3 divides into 9 3 times. And I think we're done cross-canceling. Let's be very careful to collect whatever we have left. So a minus 5 in the numerator times a plus 1 all over 3. That's your final answer. All right, we've worked on simplifying rational expressions, multiplying, and dividing. Now we'll end this lesson, or actually, excuse me, we will move to addition and subtraction of rational expressions. At the end of the lesson, then we have to talk about solving rational equations. I kind of got ahead of myself there. Okay, so we are adding a fraction to another one. The reason why you are able to add here is because the denominators are the same. Remember, the only way you can add and subtract rational expressions, or if you'd like to call them fractions, that's fine. The denominators have to be the same, okay? We are not cross-canceling because this is not multiplication. Remember, we only cross-cancel or divide out common factors between factors. These are not factors because it would have to be multiplication. This is addition, so these are different terms right now. Okay, everybody. We know that whenever you have a common denominator, you keep it, right? You keep the common denominator, and then you just add the numerators. The numerators are not like terms, so that's the best you can do. So it's as straightforward as that. You just finished adding, so good job. You're not done, however, just because you should work on simplifying if you can. The numerator factors as m times m plus 8 by factoring out the GCF of m. The denominator is a difference of 2 squares, so it factors like that. And then I notice now that, oh, we have common factors. So now that everybody's factored, now I can cross cancel, right? So now you're left with m over m minus 8 as the simplified answer, all right? Now, what you're going to see for the next couple examples is the denominators are not the same. So you're going to have to work on finding the LCD, and so that you can have the same denominator and then add or subtract. All right, you have 13x over 15y squared plus 11x over 25y. Obviously, these denominators are not the same, so you are not allowed to add these fractions. So what we'll do is we'll find the LCD. All right, if you need help finding the LCD, you can listen to the following explanation. Here is 15y squared. That's one of your denominators. 15y squared factors as 3 times 5 times y. That's prime factorization. The other denominator, 25y, factors as 5 times 5 times y. The LCD happens to be the product of each different factor the greatest number of times it appears in any one factorization. That sounded like a mouthful. Let me break that down for you. The LCD is the product of, stop right there. Okay, so we're going to multiply. What are we multiplying? Well, it's the product of each different factor. So I have to take every different factor and include it in my LCD. How many times do I include it? Well, I include each different factor the greatest number of times it appears in any one factorization. Let me walk you through that. So, I see a factor of 3. So 3 has to be included in my LCD. How many 3's? Well, just once, because it only appears one time in this factorization. So I have a 3 in my LCD. I see a factor of 5. So I have to put a 5 in here. How many times? Well, in this factorization, 5 appears once. But in this factorization, 5 appears twice. So the greatest number of times that 5 appears in any one factorization is twice. You would not say it appears 3 times because these are two different factorizations. So consider each factorization separately. It appears once. Over here, it appears twice. So you'll need 2 5's. Following that thinking, you'll need 2 y's in your LCD. So the LCD then, when you multiply all of this out, you get an LCD of 15y. Oh, excuse me. I wrote something down wrong. Excuse me. I think I got ahead of myself. Y times y. Yeah, I think I had y squared there. All right. So the LCD then is 75y squared. This is the LCD. This is what you need each of your denominators to be. Okay, so then the question becomes, what do you multiply this denominator by in order for it to become the LCD? 15y squared times what gives me 75y squared? Well, this is what I want you to see. This much right here that I'm highlighting, 15y squared, that much that I just highlighted is 15y squared, right? 15y squared. So it's right here in the prime factorization. This is why I'm such a fan of prime factorization. This is 15y squared, so the answer is right here in front of you. 15y squared times 5, do you see that leftover factor? Times 5 gives you 75y squared. So what do you multiply 15y squared by to get 75y squared, which is the LCD? By 5. And you and I know, it should go without saying at this point, that if you multiply the denominator by 5, you have to multiply the numerator by 5. Now off to the next fraction. What do you multiply 25y by in order for it to become the LCD of 75y squared? Let me use the same thinking. This much here that I've highlighted is 25y. So 25y times 3y gives me 75y squared, which is the LCD. So I'm going to have to multiply by 3y, of course, in the denominator and the numerator. So you can see this numerator becomes 65x over 75y squared plus 33 xy over 75y squared. So this is the idea. What you just did is you rewrote both of these fractions as equivalent fractions that have the same denominator. Now that they have the same denominator, now you can add. So this numerator plus this one over the same denominator. All right, everybody? And at this point, you're done. The problem is already simplified. 65 and 33 do not share any common factors, all right, other than x. Or this term and this term, they have a common factor of x. But even if you factor out the x, it will not help you simplify this any further. So this is already simplifying. Very good, you guys. All right, so example 9. What we're going to do is we're going to subtract a rational expression, this rational expression, from this one, all right? So the idea here is, you can clearly see that the denominators are different. So you and I will work very hard to find the LCD. Once we have the LCD, we can create equivalent fractions, and then we can subtract. So let's go for it. All right, we'll find the LCD the same way we found the LCD in the previous problem. I wrote down each denominator, and I'm going to factor each one, right? Prime factorization again, remember? This is how that first denominator factors. The second denominator is a difference of two squares, so it factors like this. All right, so the LCD is, remember this, the product of each different factor, the greatest number of times it appears in any one factorization. All right, I need an x plus 2 in my LCD. X plus 2 shows up once here, shows up once in this factorization. So then x plus 2, I only need one copy of that factor. X plus 3 shows up only once, so then I only need one copy of x plus 3. Now, I already have x plus 2, right? I already have that copy. I need x minus 2 in my LCD as well. X minus 2. All right, let's go back to our problem now that we know what the LCD is. All right, everybody, what I've done is I've rewritten each denominator in its factored form, okay? So I have each denominator already factored. Now, it's time to rewrite these fractions as equivalent fractions with denominators of the LCD. All right, so this is what I need to do. What do I multiply this denominator by? Everybody keep in mind that this denominator is this denominator, right? This denominator is equivalent to this one. So what do I multiply this denominator by in order to get the LCD? Well, I always tell my students, look at which factor is missing. What I mean by that is x plus 2, this denominator already has an x plus 2, so that's good. X plus 3, this denominator already has x plus 3. You know what this denominator does not have, or what it's missing, if you will? It's missing an x minus 2. So I'm going to multiply this denominator by x minus 2, and then it'll look just like the LCD. Of course, you and I know that if you multiply the denominator by x minus 2, you're going to have to multiply the numerator by x minus 2. As far as the second rational expression goes, I have an x plus 2, I have an x minus 2. What this denominator here is missing is the x plus 3. So if I can squeeze it in here, I'm going to multiply the numerator and the denominator by x plus 3. All right? So that's what I'm multiplying each of these rational expressions by. Notice that you're multiplying by 1 because x minus 2 divided by x minus 2 is 1. X plus 3 divided by x plus 3 is 1. So in essence, you are not changing the value of these rational expressions because whenever you multiply any expression by 1, its value stays the same. All right, everybody, this is what we have. X plus 1 times x minus 2, right? And then minus x minus 3 times x plus 3, all right? Now notice that the denominators are the same. They're the LCD. Let me move this up for us now, okay? I hope that's clear for you. Now, the next step is to distribute these numerators. So it's x times x, times negative 2, 1 times x, 1 times negative 2. Over here, x times 3, negative 3 times x, negative 3 times 3. Do not distribute the denominators. The denominators, keep them the same and keep them in factored form. All right, so then what you get is x squared minus 2x plus 1x minus 2 over the LCD. Over here, you get x squared plus 3x minus 3x minus 9 over the LCD. Okay. Let's combine like terms now. And the like terms I'm talking about are these. These are like terms. Over here, these just cancel because they're opposites, right? So then what you're left with is x squared and then minus x minus 2, right, over the LCD. All right. And over here, you're left with x squared minus 9 over the LCD. Alrighty. Okay, cool. Let me move this up more. Now notice that now you have two fractions, right, with the same denominator. So now you're able to actually go through with the subtraction. So you're going to have the first numerator, x squared minus x minus 2, minus the second numerator, which I put parentheses around because you have to make sure that you are subtracting x squared and you're subtracting negative 9, right, over the LCD. The same LCD, right? So you keep the common denominator. Remember, multiplication is commutative, so you can rewrite the factors. You can write them in whatever order you want down here. All right, so be careful that you are distributing that negative, right? That's something to be very, very cautious about. So then you end up with x squared minus x minus 2 minus x squared right here plus 9. That's something to be very, very, very aware of, all right? Watch your signs. Okay, so I hope you can see at this point that positive x squared and negative x squared just cancel. Like terms, though, you have a negative 2 and a positive 9, which I believe just gives you 7, right? Let's move this up a little bit more just for me to write my final answer. That should do it. So then you end up with negative x plus 7 over the LCD. And this, ladies and gentlemen, is the final answer. You have subtracted one rational expression from the other. You had to find the LCD. You had to rewrite the original rational expressions as equivalent rational expressions that have the LCD as their denominators, and then you can do the subtraction. It's kind of a lengthy process. You want to be very, very careful throughout the entire process, especially with your signs. Okay, everybody, we've walked through how to simplify rational expressions. We've talked about multiplication, division, and addition and subtraction of rational expressions. Now what I would love to walk you through is how to solve a rational equation. What I want you to notice is the instructions in all of the previous examples. Never once did it say solve. Now that this is an equation, now we say solve. Remember, we don't solve expressions. We solve equations. We have not written an equation in this entire lesson until now. So we are solving. Now, If you remember an earlier lesson, I believe it was 8.1 in our course, in the very beginning of our course, we were solving equations that had fractions in them. And you and I preferred to eliminate the fractions and then solve. Do you remember how we eliminated the fractions? I don't mind reminding you. We multiply every single term by the LCD. So our strategy here is find the LCD and then eliminate all of the fractions by multiplying each term by that LCD. I think it would be great if you had something like this in your notes. That way you can differentiate our strategy for solving a rational equation versus the strategy when we were just simplifying or subtracting or adding rational expressions. The strategies or the approaches were similar, but it's really different, right? In the previous example, we were subtracting a rational expression from another. We found the LCD, but then we built equivalent fractions, right? We wanted to get each denominator to be the LCD. That's not what we're doing here. Yes, we're finding the LCD, but then we're going to multiply. We're going to multiply each term by the LCD. This part here, this is not what we did earlier. So that's what we're doing here when we're solving a rational equation. So just be careful about being clear about, okay, what's our strategy here? Now, in order to find the LCD, I suggest you factor every single denominator, including that 4 as 2 times 2. This denominator, the GCF, is 5. And then this denominator's prime is just 5. So the LCD, now remember this, the LCD is the product of each different factor, the greatest number of times it appears in any one factorization. So I can see that I'm going to need 2 copies of 2 in my LCD because 2 appears twice in this factorization. So I'm going to need 2 times 2 in my LCD. That's the same thing as saying 4. I'm going to need only 1 copy of 5 in my LCD because it appears once in this factorization and once for that factorization. So you only need 1 copy. And then you need an x minus 7. So really, this turns out to be 20 times x minus 7. This is the LCD, right? This is what you're multiplying every single term by. So you're going to multiply this term by the LCD. You're going to multiply this term by the LCD. You're going to multiply this term by the LCD. All right, excuse my sloppy work here, but what I did is I put the LCD right next to every single term, and I am multiplying every single term by the LCD. If you do this right, you'll end up with an equation that has no fractions. All right, 2 times 2 is 4. 4 divides into 20 5 times. X minus 7 divides out with x minus 7. 5 divides into 20 4 times. 5 divides into 20 4 times. Now be very careful to write out what you have left over. Here in the front, I have 5x times x minus 7 is equal to, and then I have 4 times x minus 22 minus 4 times x minus 7. Look at this, guys. This equation seems less intimidating to solve. So now what we'll do is we'll distribute 5x. Here we'll distribute the 4. Be careful here, you'll be distributing negative 4. Be careful with your signs. Let me move us up here. All right, so after distributing, we end up with 5x squared minus 35x is equal to 4x minus 88. Be careful, you're distributing negative 4 here. So negative 4x and then a positive 28. Again, please, please, please be careful with your signs. On the right, notice that 4x cancels with negative 4x. And then you can combine these two terms here because they're constants. So that gives you 5x squared minus 35x is equal to negative 60. What kind of equation do we have as a result here? Because we no longer have a rational equation because you got rid of the fractions. We have a quadratic equation. Now, if you recall, whenever we have a quadratic equation, we most of the time set them equal to 0 and then solve. So in order to set this equal to 0, what I'll do is I'll add 60 to both sides, right? Because you want negative 60 to go from the right side to the left. That way you get 0 right here, right? So then you get 5x squared minus 35x plus 60 is equal to 0. Now here is where your factoring skills come into play here even more. You want to solve by factoring. So remember that the first step in factoring a trinomial is to see if you can factor out the GCF. And in this case, the GCF is 5. So when you factor out a 5 from every single term, you're left with this resulting trinomial inside. Now remember, this is an equation set equal to 0, okay? Don't lose that. That's very important. And then I hope you feel confident in factoring this trinomial as x minus 4 times x minus 3. The zero factor property at this point says take every single factor, and you have 3 factors here. You have a monomial factor, and then you have a pair of binomial factors. Take each one separately and set them equal to 0. Now, this is a zero factor property that you and I just used, because after all, this factor times this factor gives you 0. That must mean by logic that one of these factors must be equal to 0. Now this first statement here is silly, it's extraneous, it doesn't make sense. 5 is not 0, so I kind of disregard that one. For these, in order to solve for x, for this one I'm going to have to add 4 to both sides. For this one over here, I'm going to have to add 3 to both sides. So then I get my final solution of, I get x is equal to 4 or x is equal to 3. These are my final solutions. That was pretty lengthy in as far as the process is concerned. Remember what we did first is we factored the denominators, found the LCD, multiplied each term by the LCD to eliminate the fractions. We ended up with something quadratic. We set it equal to 0. We factored in order to solve. I thought you might appreciate, before we end this lesson, a little summary, differentiating between the processes of adding or subtracting rational expressions from the process for solving a rational equation. So check this out. I hope this is helpful. Here are the steps for adding or subtracting rational expressions. First, factor all polynomials, but the ones that are most important are factoring the denominators, but I just put factor all polynomials. Most of the problems have you factoring the denominators. A lot of times the numerators are prime or the numerators are already factored or whatever, so it's really factoring the denominators, but I just put it in factor all polynomials just to be safe. So the first thing you want to do, factor, factor, factor. After you have everything factored, look at your denominators and build or find the LCD. Remember, it's the product of each different factor the greatest number of times it appears in any one factorization. Now that you know what the LCD is, get common denominators. Once you have common denominators, then you can add or subtract, okay? Now let's look at the process for solving a rational equation. All right, to solve a rational equation, you factor all polynomials. Notice that first step is the same. Factor, 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 especially the denominators, okay? Find the LCD. That's the same second step as well. Find the LCD. Now here is where the process changes. Once you have the LCD, you are not getting common denominators. You are multiplying each term by the LCD. If you do this step right, you'll have an equation that has no more fractions. Solve that equation. Solve the resulting equation. A word about this step here. Sometimes when you eliminate the fractions, you end up having an equation that's quadratic. If you have an equation that's quadratic, like the previous example, set it equal to 0 and solve, usually by factoring. If you have an equation that's linear, then isolate the variable. Get the variable on one side, get your constants on the other. It might be helpful to have this in your notes. After you multiply each term by the LCD, sometimes you're left with a quadratic. Try this approach. Set it equal to 0. Try factoring. I say try because not every quadratic will factor. If it doesn't factor, then you might want to use maybe the quadratic formula or something like that, which we haven't discussed yet in our class. But for this point in this class, try factoring, okay? Set each factor equal to 0, and then you can solve. If it's a linear equation, then just isolate the variable, which means get the variable on one side, your constants on the other. All right, everybody, I hope this lesson was helpful for you. I'll catch you in the next lesson, all right? See you later.